In this video, I'm going to explain CNC part program for taper turning cycle, especially positive taper, how we are going to prepare a part program. Let us see. First, I want to explain how the tool movement will be there in the positive taper turning cycle. Now look at this diagram. Okay. Now RP is the reference point. From the tool is initially at the reference point, and the tool is moving from the reference point to the tool entry point. And let us here the cycle is defined as the point A, B, C, D. A to B is a rapid movement of the tool, and B to C is a given feed, while in this movement of the tool the cutting takes place. And also from C to D also the material is removed, so it's also feed, given feed. The tool will move with a given feed. And from D to A, it's again rapid movement. So wherever the material cutting not there, in that you are using the rapid movement of the tool in order to minimize the time taking for machining of the given component. Now let us see that how the tool is moving around the cycle. I want to show for clarity of the viewers. Now you can see that the tool is moving from the reference point to the tool entry point, and from this entry point to the B, this is the one path that is with a rapid movement, and B to C is the given feed, and C to the tool is lift above, and again it's coming to the starting entry point with a rapid movement. This is the one complete cycle. Okay. So like according to the taken depth of cut, we take the number of cycles required to get the required taper that you can decide. After completion of all these cycles, again the tool will send to the reference point. So this is the actual process taking place during the taper turning operation, for which we need to write the part program. Now let us see that I want to explain part program at the same time how the tool is moving. That also I want to explain in this video. First we'll see what is the syntax we are using for the taper turning cycle. So in earlier video I explained for negative taper turning cycle, same syntax is used here also, positive taper turning cycle, only that value, the difference of the radius of the tool entry and tool exit value is positive or negative. Based on that, you can call it as a positive taper turning cycle or negative taper turning cycle. Now the syntax is same: G90, X, Z, R, and F. So X is indicates the diameter to which the movement is being made, and U is the incremental distance from the current tool position to the required final diameter. The Z-axis coordinate to which the movement is being made. The W is the incremental distance from the current tool position to the required Z-axis position, and R is the difference in incremental of the cut start radius value and cut finish radius value, and F is the given feed rate. Now let us see that how we can write the part program, the code for this taper turning cycle. Okay. Now let us first take the workpiece. Now I want to make the taper of this. The outer diameter is 35 and the inner diameter is 25. So we want to make the taper in this shape. Okay. In this, for this we are using this positive taper turning cycle. Now define the calculate the radius value, that is the tool entry radius minus tool exit radius. Here tool entry radius diameter is 35, radius is 17.5. Tool exit diameter is 25, radius is 12.5. The difference is a positive value, that is the 5. The R is obtained positive 5. This is the positive taper. Now the reference point you can define for particular mission. Now I taken this is a point, the reference point. The tool will come from the reference point to the tool entry point and machining is taking place. Now let us see that the part program. First we have to write G21, G98. Already I explained what is code G21 and G98. G21 is metric units. G98 is revolutions per minute. Next, G28U0W0. Okay, so here G28 is the home position. The tool will send to the home position or reference point. Okay, now you can see that tool is reached to the reference. Wherever the position of the tool is there, first will send to the reference point. Then M06 T02. M06 is the tool change. Now I change the tool to P02. The tool change taking place. After changing the tool, then we can start the spindle in clockwise direction. Now the spindle starts with the speed 950 RPM. M03 indicates the clockwise direction. The spindle is started at the reference point. Now tool will come to the tool entry point. Now you can see that G00X35Z1. You see that whenever the block is executed, the simultaneously that tool movement also you can observe in this video. So G00, rapid movement of the tool from the reference point to the tool entry point. Here I taken the tool entry point is X35Z1. That is 1 mm in front of the workpiece at the same diameter 35 taken as a tool entry point. Now let us start the taper cycle. Now this is the taper cycle G90 X35 Z-20 R0 F55. Okay. Now you can see for the single cycle, the movement of the tool consists of these 4 or 3 motions at a time. It will take further. That is the advantage of using these cycles. Okay. Next. So you are not cutting the entire taper at one cutting, because it's not possible also. Okay, so take the according to that R value, you take the depth of cut. Okay, now let us I'm taking the depth of cut each time is 1 mm. So I have to machining this entire tapering with 5 cuts. Now let us see that first the radius 1. Okay, so X33 R1. You can see that I taken this R difference value is 1 mm, so the final diameter is reduced to 35 to 33. Next we will take the R2, okay, 2 mm depth. Then final diameter is reduced to 31. Till 25 we can make all the cycles. You can see the simultaneously how the tool is moving. So for R3, okay, so the diameter is reduced to the 29. Next R4, the diameter is reduced to the 27. We require 25. So we require one more cycle, that is R5. So it's come to the X25. Okay, now this is the actual machining takes place. Okay. Then after completion of this machining, then we'll send the tool to the home position or reference point, the G28U0W0. Then spindle stop, that is a M05 spindle stop. Then M30, the program end and rewind the tape. So with this, the entire program is completed for this taper turning cycle. I hope everyone can understand how we can prepare positive taper code for machining the component.